Alright, what's up guys? In this video we're going to pick with some multivariable calculus, and we're going to be talking about multivariable limits. So we're just asked to compute this multivariable limit. In this particular case, we have two variables, u and v, but you can do multivariable limits with three variables as well, but it's just going to be two. And so we're just asked to compute this limit. So we got the limit for u comma v is going to approach 8 comma 8. We got u to the 1 over 3 minus v to the 1 over 3 all over u to the 2 over 3 minus v to the 2 over 3. So evaluating a multivariable limit or computing a multivariable limit doesn't differ all that much from single variable limits, but there are a couple differences. One of the biggest differences is the fact that you can't use L'Hopital's rule for multivariable limits, because L'Hopital's rule only works with single variable limits. Now, if you remember from single variable limits, L'Hopital's rule was a way to get us out of a situation, in some cases, to evaluate a limit if we end up getting one of those indeterminate forms, 0 over 0, infinity over infinity. So that can get us out of a situation where the other techniques didn't work. Well, you can't do that here. There's also another way that you can deal with multivariable limits called a two-pass approach. I'll do a separate video on that, and we'll talk about that then. But outside of L'Hopital's rule, you can still use the same techniques that you use for single variable limits. So that's factoring, expanding things out, using some trig identities if there's trig functions in there. Those are basically the different ways that you can go about dealing with those, but no L'Hopital's rule, which you'll miss L'Hopital's rule when you actually start learning about this, because you won't be able to use it. So what you do for basically every limit is just plug the values in and see what happens, because sometimes you might get lucky, and if you plug it in you might get a finite value out and you're done if that's the case. But plug it in there and see what happens first. Notice that if we plug in the 8 everywhere we need to, we'll get 0 over 0, which is those indeterminate forms, and I can prove it to you. So let's just go to the calculator here. So we'll do 8 raised to the 1 over 3. Notice that gives us 2. Well, since we have 8 comma 8, if we stuck in the other 8, we'd get the same thing. So we'd get 0 in the numerator. That's not really an issue. Nobody cares about that. It's just getting 0 in the denominator that causes a problem. And I can prove that to you as well. So let's say we can do it. So we got 8 raised to the 2 over 3. Well, we get 4. Since they're both 8, if we plug it in, we're going to get 0 in the denominator, and that's where the problem comes. So we get a indeterminate form. Now, there are various types of indeterminate forms, but the more common ones are 0 over 0 or infinity over infinity. Okay, so we need to decide what we can do to try to take this limit. Well, I think the best thing to do, even though we don't have a square root in here, we can go ahead and multiply by the conjugate of our numerator and try to simplify it down a little bit, because the only thing that we're just trying to prevent is getting 0 in the denominator. So let's go ahead and multiply by the conjugate of our numerator. So in our numerator, we got u raised to the 1 over 3 minus v raised to the 1 over 3. So the conjugate of that is just going to be u raised to the 1 over 3 plus v raised to the 1 over 3. And this will have a significant impact on us being able to just plug the values in at that point. So now what we got is the limit is u comma v approaches 8 comma 8. Sorry, my terrible drawing skills. So let's go ahead and simplify a little bit. So if we simplify, what will we get? Well, if we multiply u to the 1 over 3 minus v to the 1 over 3 times u to the 1 over 3 plus v to the 1 over 3, we'll simply get u to the 2 over 3 minus v to the 2 over 3, and you can always check me on that if you like. And so what we got is u to the 2 over 3 minus v to the 2 over 3. Now don't forget, we had to do it in both the numerator and denominator. So down here we got u raised to the 1 over 3 plus v raised to the 1 over 3 because that was the conjugate, and then we're dividing all of that stuff by u raised to the positive 2 over 3 minus v raised to the positive 2 over 3. And then we just simplify it down. So we get the limit u comma v approaches 8 comma 8. And after we do some simplification, we'll simply end up with 1 over u raised to the 1/3 plus v raised to the 1/3. And that's what we'll end up when we simplify. Now, since we have a plus sign here, obviously when we stick in the h, we're not going to get 0. And we do have an addition, or we have our operation addition. So clearly here, when we just plug the values in, we're going to get a finite value. So plug them in and see what you get. Now, remember that up here at the top, when we ended up substituting in the 8 up here at the beginning, notice that we got 2 minus 2, which gave us 0. Well, in this particular circumstance, after we did the simplification, if you notice down here, we basically have the same thing, except it's just a difference in the operation. So we know we're going to get a finite value in this numerator. So if we got 2 up here and we were subtracting them, well, we'll just get 2 up here or 2 down here where we add them. So when we actually sub the 8s in and take the limit, we'll just simply get 1 over 4. And that's the actual answer. So your final answer is 1 over 4. That's the limit. So we'll say L is equal to 1 over 4. And that's how you do it. Pretty straightforward. I'll try to post more videos on multivariable limits, and we'll do one with 3 variables maybe in the next video. But that's how you take care of this one. Okay, so let me know if you got any questions. I'll see you next time.